The idea of standardizing time, rationalizing time, was, as I mentioned, deep in the French consciousness. Back from revolutionary times, you can even see clocks that were divided into 10 parts instead of 12 to make a kind of harmony with the kilogram and the kilometer. The time itself should be decimal, not this crazy system of 60 seconds in a minute and 60 minutes in an hour and 24 hours in a day and arbitrary numbers of days in a month and so on. So the idea of standardizing time to something decimal seemed like something the French wanted. And one of Poincaré's first state assignments was to explore whether there was a more rational way of dividing up the circle, the clock, than simply the 12 parts in which it's been divided, or the 360 degrees of a standard circle. So Poincaré began to explore that, and in fact came to the conclusion that you should make the decision purely as to what was the most convenient in converting to other kinds of units. What would be the least amount of multiplication? Because deep in Poincaré's system of belief, his philosophical approach to everything scientific, was that we had a lot of freedom to choose conventions about how we would proceed, as long as we accounted for the things that were observed. But within that stricture of accounting for what we observe, we have many choices. There's a kind of arbitrariness to our conventional way of doing science. And yet, Poincaré believed that choosing the simplest such system was an objective matter. That is to say, everyone would agree that multiplying by one-digit numbers was simpler than multiplying by two-digit numbers. Well, Poincaré became involved in more and more of these efforts to standardize time, to think about science in a state context. One of his tasks was working at the Bureau of Longitude. It's very hard to determine longitude, as it turns out. Latitude's easy. If you're in the northern hemisphere, you look up, you see where the North Star is. If it's right above you, you're at the North Pole. If it's halfway down, you're sort of at temperate climes. If it's right at the equator, you're at the equator of the Earth. And so this gives us a clear way of determining how distant you are from pure north. Well, the problem with longitude is that you can't do that because the world is spinning. Well, it's good the world's spinning, because there'd be other problems if it didn't spin. But because it spins, you can't just take a map and look at what stars above you and determine how far east or west you are, say, of Greenwich, because the stars keep turning. They look like they keep turning around the North Star. So you have to make a simultaneous measurement. You have to say, well, this star is above Greenwich, but this star is above me, and so I can look on my map and determine how far I am to the east or the west of Greenwich. Well, what do you do when you're on a boat? How do you determine, for instance, or you're somewhere else, not in Greenwich, and you want to know how far east or west you are? You need to know what time it is in Greenwich. Well, you could bring a watch with you or a clock with you that's set to Greenwich time, but it turns out clocks really hate to take trips. They hate it. They hate the pitch and roll of ships at sea. They hate the changes of moisture. They hate the changes of temperature. They just hate going to sea. So people would take hundreds of these clocks. Darwin had hundreds of these clocks when he went on his big expedition and try to average them. But sometimes the clocks would hate traveling in the same way. And if they all slowed down, it doesn't matter that you have 100 of them. So people began to try to measure these distances. And the best way of doing it was sending an electrical signal by telegraph. In Poincaré's Bureau of Longitude and the other bureaus of longitude of the United States and Britain, all the imperial powers were trying to map the world, to symbolically and practically have control over the world map. And so there was a kind of race that went on. The astronomers, the military affiliation would go to different places, and Poincaré would be communicating with them, and there they'd be. You shouldn't picture beautiful white lab coats at the top of a romantic mountain. You have this hut that you see here, for example, with a guy in his pith helmet who's getting a telegraphic signal and looking out his scope to see what star is right above. So you have this race to map the world. Up in the Andes and in Quito, people did an expedition to try to map the shape of the world. There were maps to try to map Africa and the great seizure of lands that was taking place by the imperial powers. It was a huge structure that was being built, cables being laid all over the world, under the oceans and over the mountains. It was a world-covering machine, a kind of internet avant la lettre. They went down the coast of Africa to Senegal, where the French were fighting an anti-insurrectionary war that went on for many years. And Poincaré was in touch with them, constantly trying to refine and modify these signals of time to try to determine longitude to map the world. All of these were very practical engineering problems that Poincaré was involved with in every way.